All right, so now we're back. All right, so we're going to look at the next thing. Now, you learned this at the beginning of the year or last semester, and we're talking about if x is a random variable, a, b are numerical constant. So if I change the value of all of my outcomes by maybe changing units or multiplying by some, well, units if it was a continuous distribution, but no matter what, if I change it in some way, the mean and standard deviation are going to be affected. All right, so mean is changed by whatever you do to it. So by addition and multiplication versus standard deviation is only affected by multiplication. So this is kind of a review. And so we're just going to use that, knowing that with our probability distribution tables. So here we go. Here's our example. It says the probability of distribution below represents y, the length of a long distance calls in minutes. So long distance call could be 5, 10, 15, 20, 25 minutes. We know, but this is what we're using for a hypothetical situation. What is the expected length of the long distance call? Okay, so the expected length of the long distance call, that would be finding the mean. And so if we want to find the mean, we would do that. Now, I got this example, and now I'm thinking about it. Technically, I should not use this example because it's technically a measurement. But I believe what happens with long distance call, once you're on it, it's just going to charge you for the 5 minutes. And once you've gone past that, they're just going to bump it at 10 minutes. So that's what they're doing. We're just going to assume that. But technically, this is a continuous distribution. But I digress. So we're going to just go ahead and finish it out. So if I wanted to find the average long distance call, I get that. Okay? So easy. We've already found the expected length because we learned how to find the mean off of a table. Okay. So the expected length of a long distance call is approximately 15.05 minutes. Okay. So now it says, here we go, same scenario. Suppose that there is an initial connection charge of 60 cents and a further charge of a cent and a half for each minute. What is the mean cost of the long distance call? So here we go. The average long distance call is 15.5. We want to remember that. All right. And so let's come up with the cost equation. So our cost equation is 60 cents plus a cent and a half per minute. So if I want to know the average cost, then I have to use the average long distance that the call takes in minutes. So I just plug in the previous average that I found right there, and I get 83 cents. So that's the average cost of a long distance call. All right, now here's the standard deviation one. The standard deviation of a long distance call is 5.68. Yes, that could have been calculated on the calculator, but I'm just going to give it to you. What's the standard deviation of the cost of a long distance call? Right, the only thing that matters when you're changing standard deviation is the multiplication. So I only care about this part of my formula. The addition does not matter. So I just use that part of the formula, multiply, and I get 9 cents for standard deviation. And that is it. That's how you do it. All right. Our last example is the combining of situations. So if you have, I think it was a bicycle problem. It was the average time to tune it, the average time to assemble it, the average time to unpack it, and those averages would just be added together for the total assembly of the bike. So that was our example. And then standard deviation, you can never add standard deviation when you're trying to combine. You take the second power, take it to the second power, and then add each second power or their variances together. You always add, doesn't matter if it's subtracting. So here we go. So a nationwide standard, and this is our last example, a nationwide standardized exam consists of a multiple choice section and a free response section. For each section, the mean and standard deviation are reported to be, here's our multiple choice average and our free response average with our standard deviation. If the test score is computed by adding the multiple choice and free response, then what is the mean and standard deviation of the test? Well, if you get the test by adding the score, then the average of the test would be the two means added together. That is the mean total test score is going to be 68 because That's what it would have been if I take the average of the other one and I just add them together. Easy peasy. Whatever mean you have to do, whatever you have to do to the actual outcomes, that's what's going to happen to the mean. Now, standard deviation, you cannot add it. You take it to the second power plus second power, each standard deviation to second power, and then you get your answer. Okay, so this is your last example. I think you guys are in good hands. I will try to send out Zooms later on today for previous assignments, for this assignment, and this is it. This is it. So I hate that we ended this way. I really miss seeing you guys. You guys made me laugh. You guys were a great stat class. I will host some tutoring sessions before the AP exam. And other than that, that is it. That'll be the next time you hear my voice in a video. Hopefully some of you guys will come to the Zoom tutoring sessions. Again, I miss you guys dearly. You guys stay safe and I hope everything goes well.